I was needing to rebuild the entire app to pull out the UI elements that were coming from third parties. I found the performance to be lacking while using these third-party UI components. So we've moved on, and I have rebuilt the two main apps. I'm not going to rebuild the reporting app because I may use those third-party components in reporting and other solutions because not only do I own the product so I can continue distributing the files, but I also have found some of the functionality to be good. But when it comes to this server, this Modbus server and this Modbus client to run on our hardware, we are going to go slim and simple. So I have rebuilt the resources. Wanted to go over a couple of tools. Now that we're not going to be thinking about the UI so much, I want to go over just how this app will ultimately run in the scenarios for the users. For example, I use a test.udl file that allows me to go in and build a connection string. Okay, in this case it was building an OLE connection string so that I could use it in my reporting app. Notice the SQL NCLI 11 string. This is not the same as the regular localDB string, yet notice that the provider does work. So this is like an OLE provider here, and then down here is the actual connection string. Okay, now either way, if you open up a file that has a UDL extension and you open it up in OLEDB core services, you are going to get a picker like this, which is going to allow you to choose a provider, a connection, where you can either click the combo box to try to get it to generate the SQL servers that are on your current machine, or you can type in the connection string, which is typically what you have to do because sometimes the servers don't come in, and typically it's good to just work with strings that you know have already worked when you were working in the SQL Server in Visual Studio. Once you have the proper server name, you can select the database, and the databases will show up. So in this case, because I'm looking at this local DB, and at this particular instance of the local DB, which is called MS SQL local DB, that's the default, it will then find the tables that I built in that SQL Server instance itself. In this case, I want to use my history table because that is the one that I have generated over here in my SQL statement, which I will show in, well actually let's go ahead and show it right here in Notepad. So in Notepad, notice it built a query. I was able to generate this from the Visual Studio solution itself. So I went to the SQL table and was able to generate a script. And in this case, it creates a table. Notice it has all our registers in it, and that's pretty much it. It creates the table and makes a blank. For localDB's sake, we're going to eventually build what's called a shared instance. And what that means is I'm going to be able to put into the config file for this solution a name of a file. In this case, it'll be the history table, so I'll be putting in a file name similar to that. And once I have put that config line in the proper config file, it will attach a database into the local user's localDB instance. Local DB server. You know, it'll build them an instance, is what I'm saying. It'll build them an instance of the database if necessary. It'll build them the table if necessary. I'm still learning the deployment strategies, yet I have decided to commit to the Microsoft Action Pack, which is the way for Microsoft partners who used to be involved in BizSpark to move forward. And it'll give me back my copies of the Visual Studio Pro editions and things of that nature that I need to be able to build good installer packages, which will not only install the apps that I am building, but also will install the SQL Server instances and the like, so that the user pretty much just walks through the wizard, and once the wizard is done, the products will work correctly according to our needs. I built some screenshots to that effect so that if someone wants to go further into it, they can look into it. And then I also attached a localDB commissioning document that has some articles in it that I found helpful in learning how to build localDB on my computer. Let's start with the mod server again. Now, again, I have shown these products off before, but only with the third-party UI components that were installed. And now that I'm no longer using those, I wanted to make sure that everything still worked. And so I rebuilt the apps until they work correctly. I start this one up. Now, I'm not going to click Start Server yet because if you remember, I have to start the Modbus server first. So I'm going to start that. I'm actually going to add something in register 4 because that is the unpacked digital register that I'm using, and I want to see it work once I fire up the regular UI app. And I'm seeding a few other values just so that I can see if things work correctly. So now there's no third-party UI for even this little button here, which actually crashed the program. I had to rebuild it from scratch, and I did. So we'll start the server here. First thing I usually like to do after that is, we won't need this, is I like to go just into the interface itself. Now this is the main HMI app. Notice I moved to a second app. The reason I want to go into this for a bit is, first off, I just want to go and see the SQL Server stuff. I want to see if the SQL Server is actually running the way I expect it to. So head over here to servers, or actually I want to go to SQL Server Object Explorer. Is a little bit easier. And again, there are screenshots in the deliverable that will show all this off. So I'll go down into my history database. This is my database here, and inside my database I have tables, and in this case I have the DBO history table, which I can look around at for a bit if I want. So I look at the creator. You know, this is the design environment, so it's a place where I can add keys. However, if we start using entity framework in ASP.NET, keep in mind that we're not going to add columns to SQL servers in the traditional way. They have a new coding model called Code First, which expects the code for each column to be iterated inside the source, and then migrations to be applied at each change so that a proper kind of versioning system can take place. And then again, notice our script down here that is the original script I showed that actually creates the table. A very nice new feature actually in Visual Studio is that I can look at all my SQL Server information in a place where I am already doing my coding. Let's go over and view data just to see if the rows are coming in. Max rows is set to 1,000. That's actually a good number. 10,000 will never slow down a view, you know, a visualization. I've gone up to about 100,000 rows before I started to see some serious performance problems and the design time experience. And the reason I moved over to those third-party UI elements is partly because I knew that it would be able to handle virtual scope, which means basically a lazy loading. It means that only load the rows that I'm looking at the time. So for example, I'm looking at these rows. Now when I'm down here, I'm looking at these rows, you know, and now I'm down here, I'm looking at these rows. Now to compare, I'll look over here and I see 22, 32, and 66, and it does look like I'm getting all those new rows, and they've been populating every 5 seconds as per the original design of the server. Liking that. So that's looking like that's all working correctly, which means we can move back into the Solution Explorer for the mod main HMI. And again, this is just the old Winnie1 app. As a matter of fact, it's still using some of the references, yet it does not have the third-party products any longer, other than, of course, the Modbus freeware. Modbus freeware is actually working stellar now. I'm not even going to go over the code because you can watch old videos to figure out the code, as well as to use the component resources that were from the third parties. It's all still good lectures because it helps go over the coding standards that are in place for those particular platforms. Yet this new video series is really to acquaint a developer with what I'll call the core code, the code that's going to be able to go on any platform. It'll be able to go on the hardware, it'll be able to go on any of the software platforms, and it will also run a web app, which will also include the shopping cart experience. I'm noticing that the form is already working correctly. If we go into the Modbus server to check our digital bit, we're looking at the fourth bit here, which is a 32. And if we look here, we go 0, 2, 4, 8, 16, 32. There's our bit going high. Again, we have high being the red or the alarm state. I can, in a very simple way, change resources depending on which way we want to flip. For example, if we want it to always be kind of a normally open architecture, we can go with the green is the high, and we just swap the pictures, and that's that. But it all depends on what we're trying to optimize. Let's do a quick check of the Modbus codes. We have register 1, register 2, register 3. Let's try register 2, and that means we're in Modbus code 2. Let's change the set point to something large, 335, and submit the change, and boom. And actually, there's the offset. So we're seeing that the offset still exists, but it's possible that I've built the text boxes in such a way that I haven't dealt with the offset efficiently yet. And I have actually commented the code in places where things need to be done. Everything does look like it works, so I'm going to pretty much wrap from there, but I do want to go and look at the source code real quick and get an idea, and then of course notice that the Modbus server is no longer running, so we get our exception as we should. I will eventually build try-catches into that. Let's go ahead and take a look at the code. Let's see. So we still have our easy Modbus reference, we have our SQL client, and then we also have that system threading, which allows us to sleep the thread, which is like right here. So while we're rolling these cyclic arrangements, I want to make sure that the threads fall asleep. Interestingly enough, even though I'm not using threading, what this basically does is it stops this thread and allows the UI to move on to another thread. Performance is increased dramatically, even if the thread sleep is a 1 millisecond. It's just to move the thread past this thread and try looking for other threads, because Windows already naturally invokes threads so that it can handle multitasking. However, the thread.sleep function sometimes is just used as a timeout. In this case, that's how I'm using it. Still got my date time, I've got my SQL stuff. This is what seeds the SQL array and the SQL server with its first values, and that's most of what's in there. And this is the mod server, so pretty simple, just the click of the button and starts the server. Mod main HMI is the one I kind of want to look at here, so I'll go into the code and let's give ourselves some room. First several lines will feed the table adapters for the DataGrid, because Windows DataGrid is actually very similar to the third-party grids. It doesn't have all the functionality, such as the virtual abstraction for scrolling quickly and efficiently, but it does have most, and I'm able to use it quite nicely. The DI array is still working. Here's where the picture boxes are being populated once the array has been unpacked for those particular digitals. Now, that's the reason I want to show this last little wrap is I've got the digitals unpacked correctly. I may not have the offsets correctly done over here with the math. It may be, I think we need to have a -1 in here, but I think I would rather put the -1 here with like an actual, I'll show you what I mean. So you could put in like an int Modbus offset is equal to 1, okay? And then you could say right here, you could say minus Modbus offset. That'll remind us that we're actually offsetting the Modbus, you see. I'm just basically using a variable instead of just a 1, or instead of actually changing the math on the original hexadecimal math, you know. It's just another way of doing things. That's most likely how I'm going to do it. And the reason I'm showing that is that that's one of the tasks of the to-do, is I was working on performance. I'm past that. I'm feeling really good about performance. Now I'm moving into checking the math, stress testing the math, making sure that the digitals are being unpacked correctly. And then there would be two other types of data, as far as I remember, that we will also need to deal with. Now, those were digitals. They will unpack and pack in all the same way. So from registers 4 through, I think I allotted 8 registers according to the notes. So from 4 to 12, those are all going to be digitally unpacked and packed accordingly. So there's to-do work on that. The next set of registers are, I think, longs. And that means that we're going to have to do some binary math on them to be able to create a 32-bit register, or basically a 32-bit enumeration. And then also the reals and the floats are going to be dealt with a certain way. For example, we might need to concatenate, since we're bringing in 2 registers that so far are just being brought into the Modbus server agnostically. We're going to need to concatenate them together, numerator dot denominator, that kind of thing. And so that kind of work needs to be done. And then the way of using those data points in the UI, not so concerned about that, because I'm able to bang out the UI very quickly. In fact, I'm easily able to put in the third-party components once we get the math going. But I wanted to make sure that there were 2 stable apps with the core source code in them, so that we could start collaborating. And that's where we'll stop.